Okay, so before we get into it though, we've done a little bit with p-values with the z-table. We've not done any of the p-values with the other two tables. And there will be a question on the test because I can't take it out because it's a Pearson thing. You have to find a p-value. So I have given you the Excel codes for all three distributions we're doing based off your claim. Right, and we're going to do this today, but just basically how you read this chart. So p-value table using Excel. So if your claim is less than, and you're doing a t-distribution, a t-stat, then you just go into Excel and type t-dist, and in parentheses you put your t-stat value, your degrees of freedom, and 1. If it's greater than, it's a right tail. If it's not equal to, it's a two tail. So there's the Excel code. We're going to go through them. And then if you like the critical value method, you can keep using the tables like you're doing. But if you want to use technology, the second table is how you find critical values using Excel. So both of these are on my OneNote. Obviously, you can use them during the test. There is a couple glitches with Excel, so I have a note here. When you're doing a not equal with your t-stat, it must be positive, so just make it positive. It's okay because it is symmetric. All right, so just make it positive when you put it into the code. If you're doing critical values, remember when you're drawing the standard over the t, they're centered at 0, so adjust your critical value to match your colored region, right? So if you're to the right and Excel gives you a negative critical value, you know it has to be positive because the right of 0 is positive, just like we do when we draw anyhow. And if you're doing not equal and a chi-squared, then you must run the code twice to find your lower and upper limit. And you also have to cut your alpha in half, which is what we've already been doing by using the tables. So you can see the Excel code is very similar to the same techniques we had to use on the tables. So that I'll be using those today to kind of walk us through how to do these things. The problem we're going to do, I think it's called lesson 9 on my sheet, but I don't think it's called lesson 9 on Excel. Yeah, it's called section 8.3, so let me update that. Section 8-3. So this is a list of 24 country average work hours per week in 2007. So what we're going to do first, we're going to see is there statistical evidence to show that the true average is greater than 32 hours per week at a significance level of 0.10, right? So if I just copy that first statement and I bring up my Excel, so let me do my new share. Now we have Excel up, right? So is there statistical evidence? So basically it's a fancy way of saying do a hypothesis test, right? That the true average is greater than 32 hours per week, right? So step 1, we still have our null and our alternative. Remember, our null is always equal to, right? And it's equal to what we believe to be true. So that is the 32. And then our claim is that it's greater than, right? So I put a greater sign symbol in and 32. So step 1, still complete. Step 2, Command X, we'll move this up a little bit, maybe, is, oh no, I don't, Command X, over there, is to find our t-stat. But before we can find our t-stat, we need a few other figures, right? We need our x bar, we need our s, and we need our n, right? And x bar is our sample mean. So remember back in week 3, to find that in Excel, it's the words equals average, right? So I highlight all my stuff with average, and I get an x bar of 32.66. S is my sample standard deviation, so I equals ST, standard deviation of a sample, highlight my data. And then to find how many countries we have, Excel has a function called count. So I hit count, then I highlight all my data, and there's 24 countries, which is actually exactly what I said as well on the thing. So let's label these. So here's step 1. Here's we found our statistics. Here is step 2. All right, and remember our formula for T-stat. So we go to our pullout, go to chapter 8.
And quick question.
Yeah.
How did you get the symbol that you have next to the null?
I copied it from OneNote.
Oh, okay.
But there is symbols in Excel, but it's easier just to copy it from OneNote.
Okay, thank you.
I basically highlighted that whole first sentence in OneNote and pasted it in here.
Okay.
So to find T-stat, we go to our pullout, and it is equals, parentheses, our X bar minus our mean, close parentheses, divided by parentheses, our standard deviation divided by the square root, so SQRT of n. I'll stop there for a sec. So all I'm doing is what you did before. And again, you don't have to do this. Even if you don't like to, then you can always use the formulas from chapter 3. But you got to remember how to do all the formulas from chapter 3. I highly encourage you to use technology. But again, if you don't want to, then you don't have to. We've learned how to find these by hand in chapter 3. So go either watch the video for 3 or find your notes from chapter 3. I recommend you use the technology though and let it do the statistics for you. And then to find my T-stat, I just use the formula. And if you don't want to type the formula into Excel, then just use those values and type them into your calculator, because we did the same thing that we did last class. But that's how I would type it in on Excel. And I'll upload this as well afterwards for people that are just watching and don't want to get confused. I'll upload the answer key. Right, so if I hit enter, I must have said in parentheses somewhere. Let me double check they got it right. Yep. So I got a T-stat of 0.9857.
That wasn't what I got.
Yeah, that seems awful high. So let me figure out what I did wrong here as well. I'm going to check it on my calculator just to be double checking here. 32, 32.6. Standard deviation of 3.26. Sample size of 24. We are yeah. And that's what I got that way.
How did I type it wrong?
E6 minus E3 divided by E7.
So X bar.
Yep, so 32.66. Mine, it might be off a little bit in the decimals because Excel doesn't round. So there's probably more numbers after the 32.66.
Oh no, mine's way off, so I'm not really sure what I did.
Yeah, because when
So it's X bar minus the null.
yeah, so make sure that's in parentheses. So 32.66 minus 32.
Yep.
Close parentheses.
Yep.
Divided by parentheses 3.26 divided by the square root key, and then put in 24, and then depending on your calculator, you might have to put 2 sets of parentheses in at the end.
Well, I was doing it in Excel, and I have nothing like I have the same exact numbers that you do.
You have all the parentheses in the same place?
Yeah, and that's not what I got.
So equals parentheses, E6 minus E3, close parentheses. Make sure you hit the division line.
I found my problem.
Okay.
I was missing one parenthesis.
Yeah, it is very, and if you do this on your calculator, you might get something like 0.99, which is okay. Again, it's all based on rounding. So, like our chart said, if we are doing a greater than problem, right, and we do to find the p-value, it's equals t dot dist, and I am doing a right tail because it's greater than. Then I put in my test statistic. So I'm just going to click on that cell, and I put in my degrees of freedom, which is just my sample size minus 1. And you can see I'm letting Excel do all my calculations for me. So t.dis.rt for right tail. Put in your test statistic, put in your degrees of freedom, and hit enter. And I get a p-value of 1.672. Right, so just because we always like to draw a picture so everybody can get a visual of what's going on here. And I did my annotate. So I draw my picture. It's centered at 0. I am doing a 10% significance level, and it's a greater than. So that means I'm up here. And my colored region is 10%. Right? So this is everything that we've been doing for the last week or so. All right, and I got that value from my significance level. Now, what we were doing before is we were finding a critical value. We'll get there in a second. I'm showing you the p-value trick. So now if I change my color to red, I got a p-value of 0.16. Well, if this is 10%, I need to add another little bit more here, right? And I'll color this way. And this is the 16.7%, right? So there, remember our p-value rules. If my p-value is bigger than my significance level, I do not reject. So I can already jump to step 5. I do not reject because the p-value is greater than my significance level. Right? Now, if you want to do what we have been doing, then we need to find, move this over a little bit. Oh, I just got to close this, that's what it is. Okay. Command X, move my critical value up a little bit. We got to find our critical value, right? And remember, how do you find your critical value? Go to your table. We're doing one tail at 10%. So that is the far right. I come down to 23, and I get a critical value of 1.319. 1.319. That's according to the table. If I want to do this in Excel, I type equals T inverse, and I am doing, there it is, T dot inverse. My probability is my level of significance, so I put 0.10, and my degrees of freedom is 23. Well, we just do like we've been doing, n minus 1, so click on my n minus 1, and I get the exact same thing. This is where I put the node in, right? Excel gave you the left critical value. I don't need the left critical value, I need the right. However, that's okay because it's symmetric, so I just make it positive, and that goes right here at 1.3. I'm sorry, no, that doesn't go right there. Erase. Wow. That goes with my significance level. Not text. Draw. Thank you. This goes with this guy, so this is my 1.319. My t-stat is what goes with my p-value, right? And that was my 0.99. So 0.99 is less than 1.319, but greater than 0. So that goes right there. And you can see, based on how we were doing it before, I still do not reject because my test statistic is not in the black bad region. So the link here is p-value goes with your test statistic, and your significance level goes with your t-crit. What's your question, Doug?
Why can't it be 3.18? The 1.318 on
23. Make sure I read the right number.
right over here you have 1.319.
Yep.
You're supposed to be 24 numbers down.
No, it's supposed to be 23 numbers down. Remember, degrees of freedom is n minus 1.
Oh, okay. Yeah. Okay. All right, never mind.
Oh, good question. So, if we go back to my OneNote, well, we don't have to go back to our OneNote. We have it all right here, right? So again, we do not reject. So there is not sufficient evidence to show that the true average is greater than 32 hours a week. So here was our, get out of my draw here for a minute. Here was our, step 3 was our drawing. So here's our step 4, right? And here's our step 5, coming to a conclusion. Step 5. And then our step 6, sorry, drawn, sorry here. Step 6, there is not sufficient evidence to support the claim that people on average work more than 32 hours a week. So here is how we do a complete hypothesis test from raw data through the steps. This is what you'll have to do if you're doing project 2. There is a homework question that goes through this. I don't think there is no raw data questions on the test though. One thing I also wanted to point out to you is if you take your pullout and you go to the very first page, right? And on the first page, it says procedures for hypothesis test. Here, these are the procedures that are out of the book, the 8 steps. Like I said, I've shrunk the 8 to be 6 because I basically took steps 1, 2, and 3 and turned that into one step. But you can see when you get halfway down the flow chart, you have a p-value method on the left, you have a critical value method on the right, so there's your thing. And then if finding p-values, there is a little flow chart right there that coincides with the Excel code I gave you. So, any questions on this problem before we continue on to another problem? Still with the same data. We're going to play with Excel a little bit longer here.
So on the test, do we have to do Excel stuff to get the final answer?
No.
Or is it?
You'll have to do it just to find your p-value.
Okay.
Just the p-value. You don't have to do all this other stuff, but you will have to do that little code that's in the OneNote to find p-value.
Okay.
Yeah, there's only one part of a question that's for.
Okay.
All right, so I'm gonna go back to my OneNote. Well, I guess I can clear all my drawings too. Annotate, clear all drawings. Close. Share. So yes, this is the answer to that question. There's the code that you have to do. So all you gotta do is just type in that one little part. You already have your test statistic found from step 2. Put that in, put in your degrees of freedom, put in a 1, and you'll have your p-value. So all those answers for that part are in the Excel. So now part B, calculating 90% confidence interval for the true average hours worked in a week. Does your confidence interval support your conclusion in part A, right? So we want a 90% confidence interval. So I'm gonna go back to share in Excel. All right, so we got our Excel back. We lost our step 5 and stuff because my drawing I had to get rid of, but we'll cut this Command X. Move it up a little bit, Command V, Command X. There we go. So that's out of our way for now. So to do a 90% confidence interval, 90% confidence interval, right? Going back to chapter 6, we have to draw our distribution. Again, we're still doing a t because the t is always of the mean. We are doing a 90%, which means I have 90% here in the middle, which means alpha is 10%, which is exactly the same number that I have up here. But I have two tails, so this becomes a 5%. And this becomes a 5%, right? And now we will do what we had to do before, right? We have to find our critical value. Well, we already found that. We found that right here. And it's the same critical value. No, actually it won't be the same critical value. I lied, because we only did a one tail up here. So if we got to find critical values, get rid of my color for a minute. Go to your table. Go to a T table. We are doing alpha over 2 is 5%, so we move over one column this time, and we come down to the 23, and we get 1.714. So this is a negative 1.714. This is a positive 1.7. Oops, why didn't I do that? 4 tab. This is a positive 1.714 based on the table, right? If I want to use Excel, I do equals T inverse. It is a two tail this time because it's a confidence interval. I still put in my level significance, so I put in 0.10. I put in my degrees of freedom of 23, and you see I get the exact same answer. So you can continue to use the tables. You can use Excel. That is 100% up to you, but we get the same values. So now, to find our lower and upper limit, we need to use the E formula, right? Our margin of error. Margin error. And that equals, so you go to chapter, pull your pull out. You go to chapter 7, confidence interval. E equals T alpha over 2, which is our critical value, times S divided by square root of n again. So we take our critical value of 1.714. We multiply it by our standard deviation of 3.26, and we divide that by our square root of 24. Those are parentheses. And now we have everything we need to finish our confidence interval. So if you're doing this in a calculator, you take 1.714 times 3.26 divided by the square root of 24. I did used Excel to do it for me. Why are you getting angry at me, Excel? There we go. And I get a margin of error of 1.14. Lower, upper. So to find our lower limit, we take our x bar of equals x bar, and we minus our margin of error. And I get 31.52. And then we take our x bar and we add our margin of error, and we get 30.38. So if I write this out in words.
Can you click on your lower limit again? I can't see what did you use?
Yep. I am 90% confident that the true average amount of hours people work is between 31.52 hours and 33.80 hours. All right, so there is my confidence interval. So my lower, I think if I double click, it makes it big. Yeah, so I took my X bar and I subtracted my margin of error. And to find my upper, I just take my X bar and I add my margin of error. I use the formula from the Chapter 7 confidence interval pullout. And again, if you don't want to use Excel for this, you don't have to. You can do it just like we were doing in Chapter 7. You can just type all this into a calculator. There's no special hotkey here. It is literally just going through and putting the formula into it that you do in your calculator. I'm just letting Excel be my calculator in this case. So part of the question was asking, does this result support part A? And there is going to be some questions on the test like this where you're going to build something. It's going to ask you to interpret the results, right? Well, if I look at my confidence interval limits, I'm between 31.52 and 33.8. 32 lies within that range. My claim in step 1 was saying that we always work higher than 32, but you see I have a lower limit less than 32. So my confidence interval and my hypothesis test support each other. They both allow the number of 32 to be in it, so therefore 32 could be the true average hours a week someone works. It could also be a little bit less. It could also be a little bit more, right? So therefore these two analysis agree with each other. Any questions before we do the last problem? All right. Oh, I'm gonna erase my drawing again. Annotate, clear. So now I go to, oh, sorry, new share. I come to this last part, C. Is there statistical evidence to show that the true standard deviation of hours per week is equal to 3? So I will copy this, copy. And we'll, running out of room. And we'll scroll down. Paste. So, again, this is a hypothesis test of the standard deviation this time, right? So, I still need to set up my null and alternative. And I'm going to have to find my symbols because I didn't put in this time. So insert. Make my Excel bigger, see if I can find this thing. No, I'll just draw them in for today and I'll figure it out later. No, nope, that's not what I want. Now I gotta move my things around now. I'll just write it out. Escape, escape, escape. All right, so we have our null, H naught. And we're going to use sigma equals, and H alternative, sigma is not equal. Let's put it in words right now, so don't waste time here. And we think it's 3, so this becomes a 3 and this becomes a 3.
Mr. Toma,
Yeah.
are you on Excel right now? Because we can't see you.
Thank you.
Say, we see your OneNote.
Thank you.
Yeah.
There we go.
All right, now we have your Excel.
Thanks. Thank you for letting me know I forgot to switch screens. I know, I wish it would just automatically switch with us. Now my Excel froze.
Why would they make life easy?
Yeah. There we go. Now my Excel's come back to me. So step 1, define your null and alternative. So sigma equals 3. Sigma is not equal to 3. So step 2, we need to find our chi-squared test statistic, right? Chi-squared stat. So we go to our pullout, chapter 8, And our formula is parentheses, our sample size, which was 24. Oh, I've got to put an equal sign and that might help. Remember to put your equal sign to make your Excel calculator. 24 minus 1, close parentheses, times my standard deviation of S squared, and divided by my sigma, which is my null, squared. And I get 27.16. So what I did here is nothing special in Excel. Again, if you don't like to use Excel, you can easily type this into your calculator. You take your sample size and subtract it from one from it, sorry. Multiply it by your sample standard deviation, square that, and divide it by your null squared, and we get our 27.1602. All right, now if we want to find the p-value here, right, and the table says that I am going to do, for not equal of a chi-squared, it's 2 times its distribution. So equals 2 times chi-squared. Why are you not coming up? Fine, I'll do it this way. Okay, equals, there we go, chi-squared distribution. Our x is our test statistic. Our degrees of freedom, again, is our sample size. I'm not going to scroll up this time. I'm just going to type in 23, because 24 minus 1 is 23. And then put our cumulative of 1 in. Oh, that is not right. I'm going to fix that code. That is not the right code. Because if I multiply that by 2, that's going to be over 100%. So I will figure that out. There is no chi-squared on the test, so we'll figure p-value out for chi-squared later. Chi-squared is the weird one. So we'll just do the old method of the critical value. That's easy. Step 3 and 4. Something's wrong with my Excel code for not equal. Draw my chi-squared. Remember, a chi-squared starts at 0. 27, we'll say is right there. And my point. So now I got to find my critical value. So if you go to your table, my chi-squared critical value for my table is, oh, and we didn't get a significance level. We'll stick with our same 10%. I'll have to add that next time. So if we're doing a not equal, there's 5%. Not equal, 5%. So 5% critical value at 23 is 35.172. A 95% lower end, which means that 95% on the table is 13.09. Make sure I'm reading the right number off the table, right? Yep, 091. And since my test statistic is in the good region, I do not reject this one as well. Which my high p-value already let me know that, but I just know I got to figure out how to do a two-tail p-value. If I want to use this to find my critical values instead of using the table, then I do the chi-squared inverse. I want to type these right below it. So equals chi-squared inverse right tail. No, yes, right tail, I think. This is 0.05, comma 23. Ah, No, I got them backwards. Command X. The good news, if you do get them backwards, they're easy to realize because the numbers go in the right place. So this is chi-squared inverse without the right tail, 0.05, comma, 23. And you get the exact same values. So tables, Excel. Look at, there is no p-value for a chi-squared on the test, so we don't have to worry about that one. But this is how you use Excel to do everything. I know it was a little fast, but I was just plugging in this formulas I already knew. The key to this was remembering how to find these things from chapter 3. So that's the challenging part of the one homework problem, is remembering to go find these values like you did in chapter 3, and then now you have everything you need to plug, substitute into your formulas. Any questions on this? And hopefully have been, yes, I've been recording, so I'll post a video of me going through this. I will update my OneNote with the right chi-squared p-value formula for two-tail. My other ones are correct. I got to figure out the two-tail one. Once I get that one figured out, I will update my OneNote. All right, so if no questions.